All right, well, let's go ahead and get started. So you get the idea. All right, so about me, like Jerry said, I'm a computer scientist / independent researcher, and I'm interested in digital typography, especially as it relates to Mesoamerican or Maya script most specifically. But I'm also interested in text encoding. We'll hear a lot about Unicode, I'm sure, throughout the conference, I already have, but I'm very interested in this topic. And specifically as they relate to ancient, emerging, or you might say new scripts, neographies, and minoritized scripts. So writing systems are obviously, they're not just symbols, they're also rules by which you compose those symbols into text. And you need both to produce a coherent text or a correct text as per the writing system. And digital typography systems differ quite dramatically in how they address this synthesis. OpenType, which we'll talk about in a second, does it one way, but there's lots of other different ways. I want to kind of explore an underexplored quadrant in that space, but what I mostly want to impress upon everyone here is that it's certainly not a solved problem. And I don't mean that in the sense of individual scripts or fonts or whatever else, but how technology is construed at a, let's say, metaphysical level. So, talk about multiscriptal typography, which is in my title, and I have here an illustration of the so-called Pentaplot dictionary. This is a Manchu Chinese, Tibetan, Mongolian, Uyghur dictionary from the 18th century. There's actually no Chinese in this image, but what's interesting about it, I'll just say it on the side. So there's Tibetan, but many people know Tibetan has a very, very deep orthography. So there's actually Manchu, I believe right here, I'm not positive about this, but Manchu pronunciation transcriptions. It's very interesting. I can't speak to that. I'm not, don't know anything about these scripts at the level of an expert, but it is interesting. But what about typography of combinations of scripts? And of course, we see a very beautiful example here. If you have in writing systems, you've got 2 in possible combinations. So if there's 172 scripts in Unicode, if you're wondering how big that is, that's a number with over 50 bits, basically. So quote, quite large. So there is a kind of seemingly unbounded degree of complexity we might have. And when we're faced with something like that, we really have to think systematically about the subject matter. In this case, how writing systems compose together. And you see in this example, it's scripts kind of nestled in with each other and whatever else, because these are, it's a dictionary, so it's these lexical entries. What I crucially, my big point here is that I don't think typography should degrade to the least common denominator in the presence of multiple scripts or multiple fonts or things of that nature. So I'll talk a bit about the status quo, which is OpenType and its predecessor TrueType, which doesn't really have any pertinent differences for the sake of this discussion. So these overwhelmingly dominate modern digital typography. And in this system, glyph shapes are represented as outlines, specified as Bezier splines. If you don't know what that is, it doesn't matter. It's just a mathematical curve, basically. But the idea is that you draw the outline, which is obviously very different when you're writing, when you're handwriting. You draw, you draw an R or something like that. Maybe you're doing kind of block lettering, like we saw in our previous talk. You might draw the outline, but that's not how you normally write in the basic case. And so-called advanced typography, this is the term that is used in kind of the OpenType world, is provided by these declarative, I'll explain what I mean by that word in a moment here, shaping models. And shaping model, and a model, by the way here, has nothing to do with like machine learning model. It's like an account. The problem is that script behavior, advanced script behavior, has to be captured ahead of time in these sets of shaping models. And I'll just note, there is something called the universal shaping engine. I'm not going to really talk about that. It addresses it to an extent, this problem. But this is a big problem for emerging scripts, because if you have a new script, you might have a totally different mechanism that is not really captured in this shaping model, which is basically like thinking about how the graphic components compose. And sometimes the models are inadequate. We see a good example of this with the so-called Indic model, where there's scripts that have sort of exceeded the capacity of that from the Indian subcontinent. Implementations typically handle runs. This is the term that's used of text individually. So what they'll do is they'll say, okay, let me get all the text that's in this font and typeset it, and then all the font in this font and typeset it. But if you have in a stream of text multiple writing systems, which are probably in a different font, or the same writing system in different fonts, it kind of degrades. You don't get the nice kerning behavior or anything like that. And there's no, and I think this is the most crucial point, there's no common abstraction over script behavior. So every script becomes every program's problem. So think about something like Egyptian, where you've got really, really complex layouts, where cursor movement is not linear or anything like that, in kind of the natural case. Well, your email program has to know about that. It can't deduce that merely from the fonts or whatever else. And finally, these are very, very complex technologies. They are so far beyond the capability of a single programmer to implement on their own. And I think that that's a problem. So I want to talk about Metafont. If you know about Metafont and you saw the title of my talk, you're probably screaming, oh, what about Metafont? So I'll talk about Metafont. It's a technology invented by Donald Knuth that's kind of a companion to TEF, which is more famous. And in Metafont, you sort of write programs in a programming language of the same name, Metafont, that generates the letter forms. So what you say is, okay, well, there's a drawing here, and it's this tall, and it's slanted to this degree for italics and stuff like that. And so you generate these bitmap fonts offline. But it is very much still fundamentally built around offline generation of letter forms. So you say, okay, make me the B, the capital B, the lowercase b, the capital T, lowercase t, etc., individually, and then you have a separate scheme, which is kerning really. That's about it, that you combine these. So there's really minimal support for advanced typography in the OpenType sense. So I hope that this will make sense. I've been really struggling on how to explain this concept that I'm calling the curse of declarativity. And so in computer science, we often talk about this sort of declarative or procedural languages. So think about HTML and CSS versus TEF. And the intuition here is like, in a declarative language, you're kind of describing what you mean in an abstract sense, but not how to produce it. Whereas a procedural is a procedure. It says, okay, we'll put this here, put this here, put this here, put this below this. And so this is maybe not the most perfect examples, but you think about in a font, you might have some capacity to say, okay, well, TNH form a ligature. When you have an acute, put it at the anchor point for whatever that is, for a vowel, et cetera, et cetera. In a more procedural sense, which what I'm going to try and introduce here, you kind of describe the procedure by which you typeset something. So, as Occam did not say, don't multiply entities unnecessarily. But notice in this, what I'm calling this, declarative model, well, not me, but what I'm using this term for, you have to know about all the pertinent entities. So like, for example, in OpenType's index shaping model, as I recall, it has specific rules for reordering viramas, which are the vowel killer marks. But that means OpenType has to know, as a manner of speaking, or an implementation of OpenType, I should say, has to know what a virama is. It's kind of baked into the specification. So in a certain sense, we're sort of doing metaphysics about writing. We're trying to think about in the Empyrean or the Platonic realm, what are all the things that compose writing and baking them into the specification. But we are clearly, obviously, nowhere close to a theory of everything, as you might put it, with respect to writing. And are we going to trust computer scientists with that? There's the expression, beware of computer scientists bearing gifts, I suppose. But I think that there's a really important point here that I've really just begun to explore, which is the kind of paradoxical sense that these more general mechanisms can in fact be simpler. Now, I don't want to disparage this kind of declarative approach. I think it's great for humans, but not as a transmission format for a font. So I have a typography engine that I've been working on called Dubsar, after the Sumerian word for scribe. And you see that cuneiform at the top for that word in my own very fragmentary cuneiform font. But what my big claim is that fonts are functions in the mathematical sense, from abstract text to concrete forms, which is say what you see on the page. So like graphemes, if you like that kind of language. But my bigger claim is that only the sort of programmable typography has the generality required to handle all categories of human writing. And I do think I mean that in a somewhat formal sense, which is to say that, like, if you think about this, like, church Turing thesis, whatever, anything that can state anything that's computable is going to be equivalent to, Turing complete programming language, if that kind of terminology is meaningful to you. So we might as well just bite the bullet and make it programming language from the get-go. But the way that this is constructed, the way that fonts are constructed in the system is that a font kind of fully embodies the logic of a writing system in a self-contained manner. So your Egyptian font, for instance, would give you information on how to navigate the text by programmatically placing the cursor. And actually, that's on the next slide, I was going to say, but I'll tell you ahead. But all these sort of advanced typographic features fall out as modes of use of the single general mechanism. And it's drastically simpler. So I have an implementation in the programming language standard ML, which is a little obscure, but details don't matter. About 2,500 lines of code versus hundreds of thousands, if not millions, for OpenType, ArtBuzz, rendering, rasterization, and so forth, and whatever else. So here's the big ideas. So every glyph is a function, like a mathematical function. Each of these functions can access and modify the graphical state. And what I mean by that is that, okay, you have your A function, it writes an A, then the B comes after it, and the B function can look into the graphical state, it can look into the textual state, it can see or the code can, I should say, can see what was typeset before, and it can modify it. So we can do stuff like ligature substitution in this manner. Glyph functions can compute optimal layout and spacing dynamically, so you don't need to do pruning tables. What you can do is you can write code that calculates, okay, how far am I at some given distance from the previous glyph, and place it optimally. Which, if you have a font with wide coverage, this is very convenient because you have an exponential blow-up of two-letter combinations. So, and I think this mitigates what I'm calling the sort of pay-to-play problem, where programs don't need to know about the particulars of a particular writing system. It's just in the font. So stroke fonts, I use something called a stroke font. And a stroke font, that's a metafont, for example, where you really draw strokes. However, rather than outlines, I mean to say. In metafont, a virtual pin is sort of strokes along a path. So you say, oh, this pin is a circle. I have an example following slide, and you stroke it. So let me show you what I mean here. But there are limitations. Oh, I'll show you in a second, actually. There are limitations. So this is R from Computer Modern, one of the most famous fonts. And you'll see that Knuth didn't actually really use the stroke feature. He kind of drew the outlines rather than actually making the strokes. But you also see in the serif right here, okay, this serif looks like a stroke, and this leg, this is from the M in Palatino, that looks like a stroke. But it's not like a straightforward combination. There's this curve right here, right? So it's hard to decompose real world fonts into strokes. And so there's another problem also, which is that stroke fonts are very inefficient to rasterize. And I'll show you what I mean. So here we have this font, and see this is a circular pen. And the dark blue is where there's overdraw, where we stroked it twice. Because you've kind of got to drag the pen across the drawing surface. And as you see, as we fill it in more and more, it becomes dominated by overdraw, like this. So I instead espouse what I'm calling a profile-based graphics model. And this is not my invention. You'll see in the bibliography, there are several people who approach something similar. But the idea of a profile-based stroke font is that, and I have a graphical representation, you're instead specifying kind of like an infinitely thin pin nib. So there's no overdraw, and I'll show an example in a second. So my contribution here is adding a rotational degree of freedom, and we'll see what I mean here. So here are the components of the stroke. Don't let these terms about Hermite splines and Bezier splines concern you, it doesn't matter, but here you've got your center line, so you're drawing along this path. Now, the left width and the right width tell you at any given point, well, it's this thick on the left and this thick on the right, and the rotation tells you how the nib, the infinitely nib, is kind of oriented. Let's see an example. Let's put all this together. So you can see right here, here's our center line. And there's the left distance and the right distance, and there's also the rotation. But the rotation in the model can be either relative to the tangent. So the tangent is what's the slope of the curve at a given point, or the right angle in this case, or it can be independent. So here you see the rotation is just absolute. So the rotation kind of changes as per that curve I showed in the previous slide. So this is a graphics model, and my claim here is that this graphics model is strictly more expressive, at least for the kinds of glyphs that we care about in typography than the Metafont model, or indeed the OpenType model. But now, why programmable typography? Kind of already touched on this, but I think it's all the same, less complex and more general, because a programming language can specify anything that you can imagine as a program. So, but crucially, there's no need for centralization because we provided a general mechanism once. And for the skeptics who are maybe skeptical of embedding programming languages and stuff, I will note that TrueType already has an insecure virtual machine for the specific case of hinting, and OpenType itself is already Turing complete. Again, this means something to you. But the idea here is that you make things simpler by uniting all these advanced features of typography under one feature, which is just programmatic placement of glyphs. And so we again understand fonts as a function from abstract text to a concrete form. I'm going to touch on this very briefly because it might be kind of boring to many people here, but we're having stack-based virtual machines, so kind of like Java, if that means anything to you. But it is constructed to be memory and type safe, so you can't escape the virtual machine and mess around with the host computer or anything like that. But as I mentioned, every kind of endpoint, every glyph function can introspect, one might say, the graphical state and indeed the textual state, what has been entered and so forth. And I'm trying to advance the use of the term scribing, which would be like a ligature, but also a syllable block or a glyph block in the Maya script, a quadrat in the Egyptian script, to use the Egyptological term. So the programming model is based on pattern matching. And basically you have the, I don't have time to talk about this in great detail, but I also have the software is designed such that text is structured upon input. So you match some structure, some component of the text. The first match from beginning to end dispatches the corresponding code, and that draws the glyph. So think about regular expressions, kind of similar to that, if that's something that is familiar to you. So just an example of this kind of Egyptian, you have this kind of cartouche, so there's a structure here, and then you have right here this stack, right here, and so forth. So you might say, okay, well, I'm going to match on a stack that has this hand glyph and this mouth glyph that are vertical, and it'll produce that code. And I'll skip over this because it's probably not interesting. So here's some common typography features. How does the system that I've devised handle it? What about hinting? So if you're not familiar with hinting, if you try and rasterize font at a low resolution, it generally looks pretty ugly. Some of that's unavoidable because it's low resolution, but you can fix that by adjusting the glyph to work better essentially in low resolution environments. Well, in my case, the DPI, that is say the resolution, the physical resolution, is just a parameter. So the font code can say, okay, well, look, I'm parameterizing at 8 by 8 pixels. I'm going to output this glyph and so forth, or I'm going to draw slightly to the left rather than the right. What about ligature substitution? Well, we have pattern matching, so we can preemptively match a TH, an FI, whatever your common ligatures, or you can modify the graphical state. So you type an F, then the code for the I glyph could look backwards and say, oh, did you just type an F? Okay, we'll replace those two, replace the F, and type an FI kind of ligature. What about shaping? Well, I've kind of already talked about that, but it just kind of falls out of the general mechanism. Kerning is really just a special case of shaping. And multiscriptal typography, in the same way, you can kind of measure the width of previously drawn components in the graphical state. So there's no need for special treatment. Now, how do you create fonts? Well, fonts are written in a programming language called Script, which is in development and in constant flux as I figure out what is intuitive for people, but it's compiled to this virtual machine, this bytecode. I'm very interested in GUI tools, and I have some kind of personal use GUI tools, but this certainly requires further research. So this is a taste of, just to show you a real thing, this is the Dindir glyph from cuneiform, which means God, but it can also be used as a determinative for deities and deific sort of things. And so you see, we have a function here which takes in these parameters. How much is the wedge rotated and how big is it? And so it constructs these paths and then returns the paths scaled, and just take my word for it that these functions exist in the system, scaled to a particular size, to a particular rotation. And so here we have the glyph function, so it pattern matches the Dindir glyph. It has an attribute which is, say, it's the full version. In late cuneiform and Neo-Babylonian cuneiform, there are reduced forms of the glyphs that you see. So this is the full version. And you draw the wedge at length 1 at 0 degrees of rotation, 45, 90, 135 at these different lengths. And it produces the glyph pictured right here. So let's say case study Maya, this is my particular interest and indeed my original interest. You have this is the today's date, July 24th in the Maya long count calendar, typeset in my font. And there's some interesting things going on here, which is that in the Maya script, characters are squeezed in these little blocks. Now, this is a not particularly sophisticated example. It's just a date. So you have numbers and then you have the components of the date, basically. But the squeezed versions are not pre-enumerated, right? They're calculated on the fly. So I have successfully developed a Maya font, and I have a much more interesting demo I can show if anyone's curious. I have my laptop with me. At some point in the conference, but allows for correct placement of these glyphs within these quadrats, these blocks, and interactive text input and editing, which I believe is a first for the Maya script. And I think it's a testament to the flexibility. So, and finally, the system has no Maya specific features, which was a kind of no cards up my sleeve. See, I've got my sleeve rolled up. So, future work, prepare the code for public release. That's an ongoing process. Add enough glyph coverage to typeset original Maya text. Well, as best as one can do such a thing, since the script is not fully deciphered. Definitely interested in working with Egyptian and, of course, modern scripts. And here's my references, and that's it.
Thank you for keeping the time. Question again.
Yes, thank you. First of all, I applaud with both hands the idea of programmable typography.
Oh, well, thank you.
I'm doing that in my research as well.
Okay.
If I could, I would upload with my feet, but I can't.
What was that?
If I could, I would upload with my feet.
Oh, thank you so much.
I couldn't help but notice that you praise essentially the imperative programming paradigm.
Yeah.
And at the same time, you mentioned pattern matching, which is a declarative programming.
Yeah.
So I believe you're actually mixing both, which also, in my opinion, is a good thing. But since you seem to be using pattern matching for ligatures, for instance, one way to avoid doing that and going back to the fully imperative style would be, for instance, to do some kind of look ahead. Because contrary to kerning, you cannot just look back.
Yeah, that's true. Yeah.
But if you do some look ahead, you can probably avoid being declarative at all.
So I'll say two things on here. The problem with look ahead, of course, is interactive input because you don't know what someone will type. And so there are some, and if you're thinking about like regular languages, I'll try not to bore the rest of the audience here, but when you introduce we'll talk about that later, but I'll say about the declarative part, I actually compile down to like a state machine. That's the transmission format actually. So it's actually not, it's pattern matching at the user level. But anyway, thank you so much.
I've got two very short ones. Sorry if the first one might be asking some things. The first one is whether you have looked at something like graphite or AAT. And whether those systems were capable of doing any of this. And the second one is, what is your proposal to convince, let's say, the IT manager at HSBC or Shell or Coca-Cola to install a piece of Java in their computer?
Okay, those are both great questions. So I'll just say Graphite, for those who are not aware, is a kind of open type competitor developed by SIL. It works, it's pretty similar to the universal shaping engine, although I would say Graphite is more flexible. It was a big influence. I'll say, I'm very aware of Graphite and AAT. They were big influences. The thing about Graphite, though, is that it has this, you're basically making a state machine, basically.
Yeah.
And I think you could generalize that even further, because it's still reliant on true type for hinting, and the true type hinting architecture is like a mess.
Yeah.
So, as for your second question, how do you convince the IT world? I was in that world for a very long time. And I'm gonna give a kind of pithy answer, but it's amazing what the tech world will do in some cases, but not others. So for example, there's no shortage of manpower, human power to rewrite things constantly. I think all of these things are technically tractable. The question is one of political will. And if you're willing to force people's hands for something better, I hope my thing is better, maybe it isn't, but if it is, they will adapt. You see the same thing.
You don't see an issue with security?
I don't think so, no, because you see like WebAssembly, for example, if you're familiar with it.
Yeah.
WebAssembly is like a proven, like mathematical degree of safety. I think if you can show that, and I think I'm working on a proof in Rogue, if you're familiar with it. Anyway,
Okay.
we can talk more about it.
Quick question.
Yes.
Are you aware of the WASM shaping work that's doing?
Yes. That was I can't say it's an influence because I learned about it after I started, but the WASM shaping model, I would say in HeartBuzz is similar. It's more advanced than Graphite, but it's similar in the sense that it's still using this kind of complex machinery for something very specific. So there are still things it can't do. It can't make new shapes on the fly.
It's only glyphs.
Yeah.
Use existing glyphs.
Yeah, exactly. But good question.
Super quick one.
Yes.
I don't think 2000. My brain goes to, okay, question won't like this statement. My brain goes to, if there was like, you can get pretext, it came out like a few months ago, secondary way of rendering text on a browser. I wonder if there's an integration for pretext with other stuff, to make it more accessible.
What came out?
Is this open source rendering framework for text in browsers with pretext?
Pretext, I'm not familiar with it, but maybe we can talk more and you can tell me about it.
I'm not a programmer, but
Yeah.
it made big news in several research.
Okay, I actually had not heard of this. I guess what I would say is that I think that you could probably use like a JavaScript or WebAssembly shim. In fact, that's what I've done. Actually, I have a web version of it. I can show you if you're curious. But I'd love to learn more about that. Thank you.